Hi everyone. This is SIG Scheduling Meeting for Asia Europe region. So this meeting is recorded as usual. So please behave nice and let's start. So I'm gonna share the where is it? Okay. So we have three topics, and actually I believe Dominic wanted to discuss one more thing. So maybe we have four. So first thing is from me. It's very quick. So I don't have enough bandwidth to review all the POs. So I just wanted to like propose uh one reviewing flow, including me. So if you feel your PO might need my reviews, then please just ping me on on your PO, and then I will respond with assign as soon as possible if I do want to review your PO, and otherwise I will just ignore it. So you can simply assume if your PO is ignored by me, it means I'm fine with the PO getting merged with other person's approval. So no need to do any like hold for me. So please just go ahead and merge the PO. Yeah, that's the first thing. And yeah, and importantly, ping me on Slack if you were ignored, but believe your PO is pretty critical that needs my attention, or if I reacted but not, you know, leaving review for a long time so that I can reprioritize things. Yes, that is it from me. And next one, Pawan.
Pawandeep.
Sorry if I,
Yeah,
sorry. Yeah, go ahead.
yeah, yeah. So, hey everyone. So, uh, my name is Pawandeep Singh. I'd like to propose adding identity leases to Kubernetes scheduler. The same pattern we already have for API server via KEP 1 and 6.5. Uh, I'll discuss this briefly in a doc as well. So the idea is simple. So each to be creates and maintain a lease object in kube system namespace so that the controller and operators can discover which scheduler instances are alive and clean up after the ones those aren't alive. Uh, so the primary motivation, let me maybe just I'll share my screen if that's possible.
Yeah. Do you have a permission to share your screen?
Yeah.
Oh, yeah,
Can you
cool.
guys see my
Yeah,
doc?
yes.
Yeah, okay. So, so the primary motivation for adding Kube's scheduler identity is that in a high availability cluster, multiple scheduler instances can run simultaneously at scale. But there is no standardized way today, as far as we know, to identify or track individual scheduler instances. In clusters with thousands of nodes and high port throughput, we have seen that a single scheduler leader becomes a bottleneck, and the answer to that is to partition nodes across multiple active scheduler instances. But to do node partitioning, the first thing that we need to answer is which scheduler instances are currently running and healthy. But there's no clean way to answer that. So this doc fills that a gap. So that is the proposal. Uh, if there is no question up until now, I'll probably talk about the use case in detail, and then what are we going to propose in this doc. Uh, okay, I'll go ahead. So the proposal is intentionally minimal. So each scheduler instance creates a lease object into a kube system namespace with a couple of labels to identify that the scheduler lease is the one we are talking about, and then the host name for identification of the host from which that scheduler instance lease was created from. So the overall life cycle would be straightforward. On startup, the scheduler would create a lease as part of start hook, post start hook, which is non-blocking. With we would have retry, so it won't delay scheduler initialization as such. While the scheduler instance is actively running, it will send its heartbeat by updating the renew time into the scheduler lease object, let's say every 10 seconds. And on, let's say if a scheduler goes healthy or it's shut down for some reason, then the scheduler lease would simply expire naturally. So the next question that comes up is who would garbage collect the expired lease? So we propose to run a garbage collection controller inside Cube scheduler. This is similar. This would be some into similar lines, just how the lease GC controller works in Cube API server, which periodically list Cube scheduler leases and delete the expired ones. So this is the exact same pattern that we are following from Cube API server. We are not proposing anything new. It's we are just extending a proven mechanism to the scheduler. So what would this enable us is with scheduler identity lease in place. Now the external controllers or webhooks can discover active schedulers by listing leases with the identity label if they want. And now we have a use case where we could partition nodes across schedulers. For example, let's say we have 3 scheduler instances and let's say 900 nodes into a single cluster, and we could distribute 300 nodes for each of the scheduler instances. And then later we have a proxy service so that we can route pods to the right scheduler by setting the scheduler name or by using a mutating webhook. So this unblocks us from natural horizontal scaling of the scheduler control plane beyond the traditional leader election system. The thing that is most important here is that this proposal does not implement uh, node partitioning or anything, or does not break anything into the current scheduler architecture. It just provides the foundation for identifying the scheduler instances. And so the scope is as same as the KEP 1965, where each of the scheduler instance could be identified by the lease object. So what I'm looking from this proposal is that a feedback on the approach. Does this seem like a reasonable fit for the upstream? And then if it does, we can work towards the KEP.
Thanks. So my first impression is that why do we need to implement it in the upstream command scheduler? Because we do not support it, like support at least with injury plugins. We do not support any that kind of no partitioning or whatever that assumes that there are a lot multiple scheduler instances. So I can imagine that you have a custom scheduler. I mean, probably custom plugin on the scheduling framework. And then the question is, why not you just do it uh, on your scheduler because you are customizing it anyway.
Yeah, so we anyways have that. We are on to a track of unforking the scheduler changes that we have done in our org, but we want this change to go to upstream so that even if there is a use case that wants to rely on the scheduler health checks, that could also take advantage of that.
Okay, Matt or Wojtek. I guess Matt first.
Okay, so what is exactly the use case where you need to know the healthiness of a scheduler instance? Like that's one question, and the other, like just for my understanding, we do have leader election for scheduler, right? As for any other core controllers like kube
Yeah,
controller manager.
so in our
And,
use case, we
Mhm.
would primarily disable leader election. So we would have let's say three active scheduler instances. Now
Okay.
we want to partition the cluster nodes so that each scheduler is aware of the partition that is being assigned to itself, and then for the incoming pods, we have a controller that would assign a scheduler instance via a via a pod label, and then by the when the scheduler has to assign a node to the given pod, it only looks at that given set of nodes that are being assigned to it, and then it's basically horizontally scalable, where you can add as many scheduler instances, and then you have those set of nodes assigned to that
Okay.
scheduler instance.
So two follow-up questions. So where exactly you need to be aware of healthiness of scheduler instance, like when
Yeah,
assigning
Yeah, so
uh,
basically for rebalance purpose, let's say a scheduler node goes into decommission or it's not there, we don't want the pods to be stuck into pending state. So basically we would, let's say one goes off, two are healthy, we would assign the remaining nodes, that set of nodes that were assigned to that scheduler instance to the remaining scheduler instances.
okay, that's one question. And the other is, uh, so we have a similar mechanism with profiles, right? When you like, it's similar in a way that you can partition cluster, but you still have only one like global active scheduler instance that handle all the partitions, right? So you're saying you see a gap. Like I understand, like the main reason here is performance, right? Or is
Right,
like,
right. Yeah,
huh?
it's basically scaling the scheduler pods throughput.
And do you have any data where you see that single scheduler instance is not enough? Like how big is the cluster? How many pods you have? Like what is the throughput? I'll be interested to
Sankalp
see
from
that. Huh?
our team, maybe do you have data? Maybe we can share that, or else I can follow up in next SIG scheduling
Sure.
Yeah,
meet.
I do have that data, Matt. Our workloads can go, like peak throughput can go as high as 800 pods per second. And our internal benchmarks, we run a lot of like controllers and other things also in the cluster. So our internal benchmarks for leader elected scheduler could only give us 200, 180 pods per second. So that was basically the delta.
I see. Okay. Wojtek?
Yeah, so I have a more philosophical question. Like I'm not per se opposed to like introducing the leader election, but like I don't see how this the identity to the leader to the leaders, but I don't see how it can be used. Like because I think if you partition the nodes, like if each individual scheduler instance um is responsible only for the like some partition of the nodes, then you need to be very smart, like deciding for a given pod or workload in general, which partition it should be scheduled on. Because like if you like put it on their own partition, it may not even fit there, even though like it fits in the other. So that's pretty tricky. Like if you, on the other hand, if you don't partition the nodes but partition the pods only to like parallelize the scheduling effectively, then you are immediately facing the races, because different like scheduler instances can schedule the pods on the same set of nodes and like step to each other toes. So I don't really see how to solve it properly, and like I think we need to like, in order to add something and complicate the scheduler itself, like I think we need to have a clear story of how like how it will be used, and if we even want to use it. Like if we don't, um if we decide that like this is not something that we want to accommodate in like upstream scheduler, then we probably shouldn't also like add the least. Like I kind of agree with like what Kenzei said, like initially, like um if we don't have a clear use case how it will be used, like adding it for the sake of adding it, I think we shouldn't be doing that because it complicates the code for no real benefit for the ecosystem.
Yeah, can I answer that question? So the way we are using it, like we use this lease to partition our nodes into like node pools, and then we have two ways of redirecting pods to a particular scheduler. One is like just basic round robin, right? And it did show us some fragmentation sometimes, but it's running in production and it ran fine for us. The future, the future in future we wanted to do load aware scheduling and that sort of stuff as well, and then people are trying to like do that as well, but this construct of being able to identify who like what is the identity of a scheduler is needed for both.
Okay, we've
So
been discussing it for enough time, I guess. I think I would propose that do you already have a issue on Kubernetes repository or not yet?
Not yet.
No, not yet.
Okay, so please just create an issue so that we can continue the discussion, and then you can link your documentation onto that issue thread so that people can get the enough context to discuss things based on your understanding and your proposal.
Sure, that works. Thanks.
Yeah,
So
thanks.
can I ask one more thing? So in the issue, if you could like describe in more details, like the use case and also the data. And I would like to see in particular the analysis saying that scheduler is the bottleneck, right? Because you are essentially saying like considering sharding the scheduler, but scheduler is part of the bigger system here, right? In Kubernetes, we have controller manager that I think also might be a bottleneck when like pod creation, stuff like that, or API server even, right? Which is like a huge single state for all the pods, all the nodes. Like we may have bottlenecks there, right? In how I don't know the throughput of watch, etc. So
Yeah.
I see like a full picture and
Yeah,
okay.
we can cover that. So we believe that bind API call is the bottleneck, but we'll cover that detail in the issue.
Perfect. Thank you.
Yeah.
Generally speaking, 800 per second, that is beyond what we observe and triggered in scheduler perf that we have in the upstream. So I can imagine that your scheduler is easily hitting some kind of bottleneck in the scheduling process or maybe binding process. Yeah, anyways, so let's continue to the next topic. I need to reshare my screen. Here we go. So this is this, and the last one, I guess, is it from Eva? I believe.
I added it, but I don't have like much
Okay.
context. Okay, but I thought we should have a look in the meeting and just like have a discussion related to it, if that's possible and if this is okay with you.
Okay. Does someone have a good summary of it? Because it's hard for everyone to read through all the things now. I mean,
Yeah, so I skimmed through it before the meeting,
okay.
and it looked like this user just has some number of nodes and deploys the pods, and in some scale-up, scale-down scenario, they hit the situation that the scheduler assigns 168 pods to one node when you have the pods per node limit, I think, to 110.
Okay, that's
And
interesting.
I don't know why.
Uh-huh. So there could be several, or I don't know, like there could be some race condition somewhere that no resource fit plugin assigns too many pods onto a single node. Is it something like that?
Yes, this would be one thing, but I cannot imagine how it could happen.
Yeah.
Maybe
Okay.
we should ask for more detailed information about the cluster. It is
Mm.
one fix by someone, but I don't think it's it's the correct one.
Okay. Okay. Yeah, it looks, interesting. So we do need to care about it. I mean, I don't. Yeah. Okay. Yeah. Anyways, it's interesting.
Yeah. So I will. Is it okay to add triage to it so we can just keep it in
Yeah.
our backlog? Yeah. Thank you.
Yeah, that makes sense.
I read it and I felt like, yeah, this is important, and this is why I wanted to have a discussion. Yeah.
Yeah, this is interesting. But I feel like, yeah, I guess we need more information from them, I guess. I don't know. At least we need to have a clear, repeatable steps to like make sure it's solved with some fixed PR or whatever. Okay. And is Dominic here? Okay. I think he's not here. Actually, I think he mentions he wanted to discuss something, or maybe not. Okay, maybe not. Does anyone have any other topics to discuss, actually? Any other PLs or issues that we need to get some attentions here? Oh, cool. I guess let's wrap it up then. Thanks, everyone. Have a nice day.
Thank you, Kenzie. Bye.
Thank you.
Bye.
Thanks.
Bye-bye.
Bye.
Bye.